In this session, we are going to study what are the types of beam. So what is a beam? Beam. And what is the difference between beam and bar? We have already read about the bar, right? What is a bar? In first chapter, we were having this type of strength of material element, and we have applied force in this direction. It means when we are applying the force to the axis of the bar, axis of this element, we are saying that this will become a bar. And same stress element, when the force is applied, in lateral direction, in transverse direction, that is perpendicular to the axis, we say this becomes beam. It is not a rigid beam or rigid bar, it is flexible. There will be deflection in this, right? Later on we will study the deflection also. Here we want to study the shear forces and bending moment of this beam, right? So beam which takes perpendicular loads. Perpendicular to what? Perpendicular to the axis of the beam. Perpendicular loads to the axis of the beam. Yeah, material, right? So this is called beam which takes load perpendicular to the axis or longitudinal direction. Axis of the beam, or you can say perpendicular to its longitudinal direction. So the same bar becomes beam when the loads are applied perpendicular to the axis, right? So this is difference between beam and bar, and this is a beam when loads are applied perpendicularly. So what types of beams are there? And if you are applying beam, it may be having some supports like this. This is fixed here. It means if it is fixed, it means this is a support for this beam. So for beam to carry the load, some supports are required, right? So first of all, let us study supports, and then we will study the types of beams, right? Before studying the supports, we will not be able to study the beams, right? So first of all, study the supports for beam. What type of supports are there to carry the beam, right? So there are basically three types of supports are there. First is roller support. Roller, R-O-L-L-E-R, roller support. What is roller supports? Which takes load in only vertical direction. Means this supports takes load only in vertical direction. Like this, that suppose in which there is a reaction, it means takes load in vertical direction. It means that the reaction at this support is only in vertical direction, right? So this type of this suppose this is a roller here, and this is a beam. This horizontal is a beam, and there is a roller, right? Like this. There is we have applied a roller here, right? So this type of support is called roller support, and there is only one reaction. Vertical reaction is there, right? Vertical reaction. I am writing RV, right? So only vertical direction is reaction is there. So only vertical reaction takes place in roller support, right? Why not horizontal reaction is there? Because it can roll in horizontal direction. When we apply a force in horizontal direction, it will move, and there will be no reaction developed in this roller support. And why it is not able to take a couple or movement? Because when we try to rotate it, it will rotate through this axis, right? So it will not be able to take the movements, right? So it cannot take movements, it cannot take horizontal reaction, there is no resisting movement taken by this, there is no resisting horizontal reaction taken by this, it will take only vertical reaction, right? You can think of a car has wheels on this, and it is moving in this direction, and it can move in horizontal direction, but it cannot go inside the earth, right? Because there is reaction taken by the wheels. These wheels are basically are the roller sports, a type of roller sports, right? So roller sports are the sports which can take only vertical loads, or they are developed only vertical reactions, right, in this supports, right? So horizontal reaction will be 0, RH will be equal to 0, or resisting moment, I am writing MR, means resisting moment, right? It will not resist any moment, right? So resisting moment and horizontal reactions will be 0, and there will be only vertical reaction. Second type of support is hinge support. Hinge support. What is that hinge support? Hinge support is in our doors also, in our almirahs, in doors, where we can rotate the door of the room or almirah, right, in this direction, right? So it means it can rotate. If we apply a movement, it cannot resist the movement, but it is not going in horizontal direction or vertical direction, right? In both the direction it is resisting. It will resist the horizontal and vertical forces, but it will not resist the movement, right? So there will be only two types of forces and reactions will be there. Two types of reactions will be there. So hinge support is like this. I am making the diagram of this hinge support like this. This is the way of denoting the hinge support. This is hinge at point, this, right? So it will resist the vertical movement of this body, and also it will resist the horizontal movement of the body, right? But it will not resist the movement. It will move clockwise or anti-clockwise, right? So there will be no resisting movement in this support, right? Hinge support. So it takes horizontal and vertical reactions. So there will be horizontal and vertical reactions are there. Right? When we say reactions, it means these are resisting forces which resist the movement of this body, right? So it will resist the movement of the beam in horizontal and vertical direction. But the roller supports will resist only the vertical movement of the beam. It will not resist the horizontal movement or rotation of this roller. It will not resist that, right? So these are two types of supports. There is another type of support, that is fixed support or fixed joint. This is roller joint, hinge joint, and fixed joint or fixed support. So third type of support is fixed support. These are also called joints, fixed joint, right? This is also called roller joint. Another name is roller joint. The hinge joint, another name is hinge joint. Hinge support or hinge joint, roller support or roller joint, and another is fixed support or fixed joint. What is that fixed joint? Here all the three reactions will be developed like this, right? This is fixed in the wall. Suppose I fix something in this board like this, I make a hole here and then I fix it here, right? So it will become a fixed joint, right? It will not allow the movement of this beam in horizontal direction, it will not allow the movement of this beam in vertical direction, and neither it will allow the movement of this in clockwise or anti-clockwise rotation of the beam, right? So it will resist all three forces, that is horizontal, vertical, this is vertical, horizontal, and it will also resist the rotation of this beam. If we apply a load here, it will resist the rotation of this beam. So it will resist, there will be a resisting movement developed in this reaction, right, at this support, right? So all three reactions, that is horizontal reaction, vertical reaction and resisting moment, will be developed in this beam. So this will called a fixed support or fixed joint. So these are the types of supports. Now we want to study the types of beams, because the beams are carried by these supports. So what are the types of beams depending on the supports, right? It will depend on the supports what type of beam that becomes. Same beam will become a one type of beam, same beam will become another type of beam depending on the supports, right? So next topic is types of beams. Types of beams. First of all, let us say what type of, if we are applying some forces on the beam, what are the forces, or if the body is in statically equilibrium, so what is the condition of statical equilibrium, right? So first of all, before we take this, right here the condition for static equilibrium, condition of body to be in static equilibrium. What is the condition of a body to be in static equilibrium, right? So if body is in static equilibrium, it means there should not be any horizontal forces. Net horizontal force on that body should be equal to 0. Net vertical forces on that body should be equal to 0, and there should not be any movement about certain point of that body, right? So this is the condition. There are three equations basically, right? We have to solve for finding the unknowns. And what is our unknown? The reactions. The reactions taken by supports are our unknowns, right? And we will be having three equations to solve these unknowns basically, right? What are the conditions of static equilibrium? The horizontal forces should be equal to 0, then the body will be in static equilibrium. Vertical forces should be equal to 0, sum of all the vertical forces, and sum of all the moments should be equal to 0. This is the condition of static equilibrium, right? So we have three equations, and if the number of unknowns are more than 3, then we will not be able to solve that problem using this static equilibrium condition, and that beam is called statically indeterminate beam if the number of reactions are more than this, right? So first of all, we will write types of beam. So we have two types of beam first of all, based on the equilibrium condition. So based on equilibrium condition, we have two types of beams. One is statically determinate beam. What is statically determinate beam? In which number of unknowns, what we mean by unknowns, it means number of reactions basically, reactions. And where these reactions are developed? Reactions are developed at the supports, right? Hinge support, roller support, or that is fixed support, right? So number of unknowns, number of reactions are less than or equal to 3. If the number of unknowns are less than or equal to 3, because we have only 3 equations to solve, then we call it that this is a statically determinate beam, right? That the unknowns can be found out using these equations only, static equilibrium conditions. We need not any other equations are required. We directly solve the unknowns using these 3 equations. But if the unknowns are more than this, if the unknowns are 4 or 5, then we call that beam as a statically indeterminate beam. So we call it statically indeterminate beam. So what is statically indeterminate beam? In which number of unknowns or you can say number of reactions. Number of reactions are more than 3. More than 3. Here 3 means number of equations for static equilibrium, right? More than 3. So then we call it statically indeterminate beam. So this is the one type of beams, right? Depending on the equilibrium condition of the beam. So this is the type of beam. Another type is depending on the supports. At what supports the beam is carried. So another part of types of beam is the depending on the supports, right? So next is the types of beam based on the supports, right? So types of beam again, types of beam. Again we are writing here types of beam depending on the supports, right? Depending on supports. Right? So first of all we have cantilever beam. Cantilever beam. Cantilever beam. So what type of cantilever beam is? That one end of the beam is fixed. One end of the beam is fixed and other is free. So this type of beam is called cantilever beam, right? So this is free end, this is free end, this is fixed end. So one is fixed end, suppose A, and this is free end, suppose B. This type of beam is called cantilever beam, which is fixed at one point and other end is free, right? Fixed at one point and other end is free. Fixed at one end. Fixed at one end and other end is free. This type of beam is called cantilever beam. Now, what are the reactions will develop here? The reaction will be developed. The reactions will be developed. We know that at fixed end there are 3 reactions basically. You know, there are 3 reactions: horizontal reaction, vertical reaction, and movement. The resisting movement, right? So there will be 3 reactions. Here is vertical reaction, horizontal reaction, and the movement, resisting movement, right? And we want to know whether it is a statically determinate beam or indeterminate beam. Here there are 3 unknowns and we have 3 equations to solve. So it is a statically determinate beam. So you must remember that this is a very important beam because it is statically determinate beam, because it has only 3 reactions, 3 unknowns, right? So we can solve these reactions using this statical equilibrium conditions. Next is simply supported beam. Simply supported beam. Simply supported beam. What is that simply supported beam? The beam which is supported by a one hinge joint. There is a hinge joint. There is a hinge joint, and another is a roller joint. Another is roller joint or roller supports. There are 2 supports, right? There are 2 supports to carry this beam, and this is called simply supported beam because it is supported by 2 joints. One is hinge joint, another is roller joint, right? So which is supported by one hinge joint and other roller joint or roller support, right? So this type of beam is called simply supported beam, right? Now we want to know whether this beam is a statically determinate beam or statically indeterminate beam. If number of unknowns, number of reactions are 3 or less, then we can find out the reactions using these 3 equations, and this will be a statically determinate beam. Let us see here. Now we know hinge joint. At hinge joint there are 2 reactions, 2 unknowns are there. One is horizontal and another is vertical. So this is vertical reaction and this is horizontal reaction. So it will be having maximum 2 reactions. It is not having any movement. Resisting movement will not be there, right? And roller joint have only one reaction. It can only resist the vertical movement of the beam, right? So there will be only vertical reaction, right? Suppose this is RV1, this is RV2. So there are 3 unknowns basically, 1, 2 and 3, and there are 3 equations to solve. So these 3 unknowns can be found out using these 3 statical equilibrium conditions. So this is a statically determinate beam, right? So number of unknowns, number of reactions are are 3. You can hear there are 3 reactions. So these are statically determinate beam. Statically determinate beam. So this is a statically determinate beam, right? So 2 types of beams we have read. Let us see another type of beam, that is fixed beam. Third type of beam is fixed beam. As the name suggests, fixed beam. It means it is fixed, but it is not cantilever beam. It is fixed at both ends. It is opposite to cantilever beam, in which the beam was fixed at only one end, other end was free. But here, in this case, it is fixed at both the ends, right? So this type of condition is there. This beam is fixed at both ends, here as well as here, right? At both ends this beam is fixed. So it is supported by fixed joint at both ends. It is supported by fixed joint here as well as here. So that type of beam is called fixed beam, right? Now we want to see how many reactions are there. How many reactions are there in this beam? You can see here, this is a fixed support. It will be having a vertical reaction, a horizontal reaction, and a movement, resisting movement. So I am saying it 1, 1. So 3 reactions are there at joint A. Similarly, there will be 3 reactions at this joint. There will be vertical reaction RV2, there will be horizontal reaction, suppose RH2, and there will be a reaction at this joint also, suppose like this, or it may be opposite, whatever it is, so MR2, right? It means how many reactions are there? 6 reactions are there. So here there are 6 reactions or unknowns are there in this beam. In this beam, we have to solve these 6 reactions, 3 at point A and 3 at point B, right? So if this is 3, it is more than 3. If it is 6, it is more than 3, because we have only 3 equations to solve. So we have to apply some other technique to solve these reactions. We cannot solve by our equilibrium conditions, which are sigma fx is equal to 0, sigma fy equal to 0, or sigma m equal to 0. We cannot solve by these 3 equations only. We require 3 more equations to solve the 6 reactions, right? So basically it is a statically indeterminate beam. Statically indeterminate beam. So this is a statically indeterminate beam, right? Next is continuous beam. Continuous beam. What type of beam is this continuous beam? Continuous beam. Suppose we have a hinge joint, and there are, because beam is long enough, so we have 2-3 supports here to support this beam, right? So this type of beam where there is more than two supports are there like this, we call it as a continuous beam, right? So there is more than two supports, right? More than two supports are there, so this is called continuous beam, right? Now how many reactions will be developed in this beam and how many unknowns we have to solve? One is the vertical reaction by this point, hinge point. One is horizontal reaction by this hinge point, right? So there are two reactions at this hinge point. You know that at hinge point there are two unknowns, two reactions, vertical and horizontal reactions, right? At roller joint there is only one reaction, that is vertical reaction. Suppose RV2, and at another also there will be one more reaction, RV3. So we have three vertical reactions and one horizontal reaction. So we have four unknowns, four reactions at this continuous beam in this case, right? There may be more roller supports. We have shown only two roller supports and one hinge support here. So here in this case there are four reactions. Four reactions are there, right? In this case, where we have two roller supports and one hinge support. And because the reactions are more than three, because we can solve only three equations through statically determinate beam, right? So it is a statically indeterminate beam. So statically indeterminate beam. So this is basically statically indeterminate beam. One more type of beam is there, that is called overhang beam. That is nothing but simply supported beam, but the name, different name is given to it, that is overhang beam. Oh, what is overhang beam? One of the end is hinged and the another end is not given a support of, that is a roller support, but the roller support is given at certain another point inside here, and some part of this beam is hanging, overhang. So that's why we are call it that overhang beam, right? Some part of the beam overhangs. So this is called overhang beam, right? So how many reactions are there? The reactions are similar to the simply supported beam. Three reactions are there, and that's why this is a statically determinate beam. So this is a statically determinate beam. So this is a statically determinate beam. So these are the five types of beams which we have in our syllabus, right? So we have what type of beams are there? If we summarize this topic, one is statically determinate beam, in which the reactions or unknowns can be found out using the equilibrium condition of static equilibrium condition, right? Sigma fx is equal to 0, sigma fy equal to 0, and the resisting moment equal to 0, right? So three equations we have, and if the reactions are 3 or less than 3, then that beam is called statically determinate beam. Otherwise, if the reactions or unknowns are more than 3, then we call statically indeterminate beam, right? So two types of beams are there, statically determinate and statically indeterminate. Then depending on the supports, at what supports they are carried, so we have different types of beams. Like first we have cantilever beam, in which one end is fixed and other end is free, and that was statically determinate beam because three reactions were there. Then we have simply supported beam. In simply supported beam there are two supports, one is hinge joint and another is roller joint. At hinge joint we have two unknowns or two reactions, at roller joint we have one reaction. So there are three reactions are there, and that three reactions can be solved using static equilibrium condition, right? So that is also a statically determinate beam. Then we have fixed beam that was fixed at both the ends. So there were 6 reactions were there. There are 6 reactions are there like this. This is the fixed beam. So 6 reactions are there. So unknowns are more than 3. That's why this is a statically indeterminate beam. And then we have continuous beam. In continuous beam we have more than 2 supports like this. We have hinge support and roller supports, right? So number of reactions are more than 3. So we have, this is statically indeterminate beam. And another is overhang beam. This is similar to simply supported beam because 2 supports are there, hinge support and roller support, but some part of the beam overhangs. That's why it is called overhang beam, right? And number of reactions are 3, so it can be solved very easily. So this is a statically determinate beam. So these are the types of beams.